In this video, we are going to look at transformers. Now, a transformer can be defined as an electrical device that converts the voltage of an AC supply to either a higher or lower voltage supply. Now, we'll begin by first drawing a simple diagram for the transformer. Then also this same transformer has two coils. One is known as the primary coil and the other one is called the secondary coil. Now the primary coil is found on the left side. So this is our primary coil. Then we will have the secondary coil on the right side. Then from there, the other thing that we need to know here is the primary coil is considered to be the input. This can be the input of voltage or current. Then our secondary coil is considered to be our output. Away from there, then if we look at the operation of a transformer, the transformer operates on a phenomenon known as a mutual induction. So the mutual induction talks about how the current that passes through the primary coil creates the alternating magnetic field lines that will induce current on the secondary coil. Now, we also have this iron core, soft iron core, and the reason why soft iron core is used, the reason behind that is that the iron core is easy to magnetize and also easy to demagnetize. Now, after knowing these basics, the other thing is we may have a picture of what happens if a transformer is working or under operation. So the first step that you need to know is the primary coil. The primary coil is always connected to alternating current. So here we have the AC. Then the second step, what happens if this alternating current passes through the primary coil? So when alternating current passes through the primary coil, it creates the alternating magnetic field lines. So I'm trying to give a picture. This in green denotes the alternating magnetic field lines. So when these alternating magnetic field lines passes through the secondary coil, and the alternating voltage will be produced. So these are some of the steps or points that you may give if you are asked to define or explain how a transformer operates. Now, away from these ideas, let's look at the two types of transformer. So the first one, we'll look at the step-up transformer. So a step-up transformer is a transformer that converts low voltage into higher voltage. For example, if you look at the transformer that is in inverters, those inverters that are connected to a battery. So a battery has about 12 volts. So the battery has about 12 volts. Then the inverter will give you the output voltage of about 240 volts. So we can see that the voltage has increased. So this is what we call a step-up transformer. Now, under the same step-up transformer, we need to look at how can we identify the given transformer if it is either a step up or step down transformer. So for a step up transformer, we are saying the output voltage must be greater than the input voltage. So on the secondary party, we are expecting to have more turns than on the primary party. So this is the first thing that you may encounter or that you can use to identify a step up transformer. So mathematically, we can show this. We can say number of turns on the primary coil is less than number of turns on the secondary coil. And remember, whatever point I'm looking at for now is for a step-up transformer. Let's take it for instance. We have 50 turns on the primary coil and 100 turns on the secondary coil. So if we do mathematics, we can see that there was a certain number that was used to multiply the 50 turns to get 100 turns. So we can see that the ratio here is 2, or it was 1 to 2. So 50 times 2, we have this 100 turns. Now let's look at also in terms of voltage. So for voltage, if the primary voltage, let's take it for instance, we have 12 volts. Then if the question is find the output voltage, the voltage on the secondary coil, so this, remember, the voltage is in the direct proportional to the number of turns. So what this means is if we have 12 volts here, we are going to have 24 volts on the secondary coil. How do we get this 24? We are going to multiply by the same number, which is 2. So what the picture here is, the same number that you have used to multiply the number of turns should also be used to multiply the number or the output of voltage. So here we are expecting to have 24 volts. So under mathematically symbols, the voltage on the primary coil must be less than the voltage on the secondary coil, given the transformer is a step-up transformer. Now let's look at what of now current. So current is the opposite. The current on the primary coil must be greater than the current on the secondary coil under the step-up transformer. So this time let's say here we have 6 amps. If we have 6 amps on the primary coil, we are going to have 3 amps on the secondary coil. So here for current, we are going to divide, since the number of turns and voltage were multiplied by 2, but for current we are going to divide. So the key point is 50 times 2 will get 200 turns. Then 12 times 2 will give us 24 volts. 6 divided by 2 will give us 3 amps. So these are the basics about the step-up transformer. Now let's look at the step-down transformer. So the opposite of what we've looked at is true for a step-down transformer. So the first one, we need to define what a step-down transformer is. And a step-down transformer, it is just a transformer that converts high voltage into low voltage. Now, why are we converting high voltage into low voltage? There are some of our electrical appliances that may want the voltage in a lower level compared with the voltage that is being produced by the source. So the first step, we'll look at the number of turns. So the number of turns on the primary coil this time will be greater than the number of turns on the secondary coil. Okay, so then we can now make the same numbers but opposite. So this time, let's say we have 100 turns on the primary coil, then we have 50 turns on the secondary coil. So we can see that this time, instead of multiplying, we are dividing by 2. So 100 divided by 2, we have 50. Now let's say we have 24 volts as our input voltage. What is the voltage on the secondary coil? So we are going to do the same. We'll divide by 2. So 2 into 24 will give us 12 volts. Now for current, if we have 3 amps, we are going to have 6 amps here. So for current, you multiply by 2. So under mathematics, we can say number of turns on the primary coil for a step-down transformer is greater than number of turns on the secondary coil. The input voltage is greater than the output voltage. Then the input current is less than the output current. Okay, so now since we have some ideas about the step down and step up transformer, let's look at some calculations or equations involved in an ideal transformer. So an ideal transformer can be considered where there is no loss of energy. So the first formula that we are going to look at is we have the number of turns on the primary coil divided by the number of turns on the secondary coil is equal to the input voltage divided by the output voltage. Then the second equation is the power, we'll say power input, which is power on the primary coil, must be equal to power on the secondary coil. And we know that power is equal to voltage times current. So if we substitute here, we are going to see that we are going to have voltage on the primary coil times the current on the primary coil is equal to voltage on the secondary coil times the current on the secondary coil. Then the other equation that we can use, if given the efficiency is less than 100, we can say efficiency is equal to power output, so power on the secondary coil divided by power on the primary coil multiplied by 100%. So this will give us now voltage on the secondary times the current on the secondary divided by voltage on the primary times current on the primary multiplied by 100%. So these are 3 equations that we can use under the introduction for transformers. Now let's look at some examples. Okay, so now we have the first example. The figure below represents a transformer with a primary coil of 100 turns and a secondary coil of 200 turns. Now we can start it. So from the first question, we have told to give the type of the transformer that is shown on this figure. So let's first analyze. So we can see that the number of turns here greater than the number of turns here. So under mathematics, we can say the number of turns on the primary coil are greater than the number of turns on the secondary coil. So with this information, we can be able to identify the type of transformer. So we are dealing with a step-down transformer. If you are told to give a reason for the answer, you need to say because the number of turns on the primary coil are greater than the number of turns on the secondary coil. Now let's look at question B. The primary coil is connected to the 240 volts AC supply. Calculate the secondary coil. So the input voltage is 240. Then we want to find the output voltage. Now, what do you think our answer will be? Are we expecting to have the number greater than 240 equal to 240 or less than 240? Now, since we are dealing with a step-down transformer, we are expecting to have a number less than 240. Now, let's look at first we'll begin with the number of turns. So for the primary coil, we have 400 turns. Then if the secondary coil has 200 turns. So since the number decreased, this means that there was a certain number that was used to divide 400 with. So we can say that if we divide 200 to 400 is 2. So this means that 400 divided by 2 will give us 200. So the same ratio that was used to find the number of turns of the primary coil will be used to find the voltage on the secondary coil. So on the primary coil, we have this voltage of 240. So what is the voltage on the secondary coil? It's 240 divided by 200. So this will give us 120. So it's basically here, the point is we are just finding the half of that, since the number of turns on the secondary coil is half of the number of turns on the primary coil. Now let's also say if we want to, we can also find the same answer by using this principle of cross multiplying, where we have the primary and the secondary coil. So let's look at what we have. We'll begin with the number of turns. So the number of turns on the primary coil is 400. The number of turns on the secondary coil is 200. Voltage on the primary is 240. Voltage on the secondary we don't have, so we put X. So cross multiply. 400 multiplied by X will give us 400X. Then here we are going to have 200 multiplied by 240. So we divide by 400 since we are solving for X. Even here by 400. So X is equal to, if we cancel these 2 here is 1, 2 here is 2. So we can see that 2 into 240 will still give us 120 volts. So this is our output voltage. Now for the formula, we can also use the formula where we said number of turns on the primary divided by number of turns on the secondary is equal to voltage on the primary over voltage on the secondary. So number of turns on the primary is 400 over 200 is equal to voltage on the primary 240 over Vs. So if we cross multiply, we can see that we are getting the same answer. So we divide by 400, even here 400. So voltage on the secondary coil is still 120. So you can use any of these 3 methods to come up with the answer. So move on to question C. Explain carefully how a transformer works. So here I will just state some points that you need to write. So the first point is you need to say the primary coil is always connected to the alternating current source. Then point number 2, the alternating current source will produce alternating magnetic field lines. Then point number 3, the alternating magnetic field lines will induce current on the secondary coil, which will produce alternating voltage on the secondary coil. So those are points that you need to give. You are explaining how the transformer works. Then for question D, why soft iron used for the core instead of steel? So the reason why they use soft iron is because iron is easy to magnetize and easy to demagnetize. The disadvantage of why they can't use a steel is if the steel was to be used under transformer, it may take time for it to demagnetize. Thus, it may take time for an appliance to switch on. So you may find it that you switch the appliance on, it may take for some minutes or maybe hours for it now to start working because of its magnetism. Now let's look at the question E. If the current in the primary coil is 3 amps, calculate the current in the secondary coil assuming the transformer is 100% efficiency. So we'll begin by first we need to look at we said number of turns on the primary greater than number of turns on the secondary, point number 1. Then we say the input voltage greater than the output voltage. Now for current, remember current will be opposite, so current on the primary must be less than that on the secondary coil. So if current is on the primary must be less than that on the secondary, we are expecting to have a number greater than the 3 amps. Now, if you remember, we said for us, we have 400. For us to get 200, we divided by 2. Then 240 divided by 2, we have, we got 120. Then 3 amps. Instead of dividing, this time we are going to multiply by 2. So this time we are going to get 6 amps. Now let's find the 6 amps by using the formula. So the formula that we are going to use is voltage on the primary times current on the primary is equal to voltage on the secondary times current on the secondary. So the voltage on the primary is 240. The current we are given is 3 amps is equal to the voltage on the secondary is 120, then times the current on the secondary. So if we multiply, we can multiply if we want, or we can just let the numbers be the way they are. So times 120 is. So for us to isolate is, we divide by 120, also here by 120. So let's do math now. So 120 to 120 is 1. 120 into 240 will give us 2 times 3 will give us 6 amps. So this is how we can get the answer. Or if you want, you can say 240 times 3 will give us 720. So if we divide 720 by 120, we'll still get 60 amps. Now let's look at how we can see how this formula came into existence. So we know that efficiency is equal to power output, which is the voltage on the secondary coil times current on the secondary divided by voltage on the primary times the current on the primary multiplied by 100 percent. So since the efficiency is 100%, we can substitute the efficiency here. So this will give us efficiency of 100 is equal to, let's just leave these expressions, so VS times IS over VP times IP multiplied by 100%, so over 1 we can cross multiply. So if we multiply, we get 100% VP times IP is equal to VS times IS times 100. So you can see that if we divide the both side by 100%, even here by 100%, you are going to get this formula. So this formula can only be used if a transformer is 100% efficient. Now what happens if you have a transformer that is not 100% efficient? So for that transformer, you need to use the formula, the efficiency. So you just say efficiency is equal to power output, which is voltage on the secondary, times current on the secondary over voltage on the primary times the current on the primary multiplied by 100%. So here, this is where you substitute the efficiency that is given. As long as it is less than 100, you use this formula here. Okay, so now let's also have some ideas about what happens if you are given in terms of power. So we can now calculate the power output. So for power, we know that power is equal to voltage times the current. So on the secondary coil, the voltage is 120, then our current is 6 amps. On the primary, we have 240 volts and current of 3 amps. So if we want to find the power on the secondary, which is the power output, we use this number times this number. So it's 120 times 6. So if we multiply 120 times 6, we get 720 watts. Let's also find the power input. So power on the primary, voltage times current. So voltage is 240 times 3 amps. So if we multiply 240 by 3, we get 720 watts. So we can see that the power on the primary must be equal to the power on the secondary. That's why we have this formula of VP times IP is equal to VS times IS. So this means the power. Also this means the power. So the power must be equal to, for you to use that formula. So these are just the basics about transformers. If you need more of these questions, please feel free to write in the comment section below. And if you are watching this video for the first time, or maybe attending this channel for the first time, please I urge you to subscribe, hit the notification bell so that you are notified, and don't forget also to share with families and friends so that we may learn and grow together in knowledge. Now the other thing here is for a step-down transformer. For a step-down transformer, the one we are looking at, the information, if you are to be given a step-up transformer, the opposite of what we have looked at can give us a step-up transformer. For instance, if 120 is on the primary, the 240 must be on the secondary. So you just have to look at the opposite of the information. For a step up transformer, you have the step down, and vice versa. So that's it for this video. Thanks for watching.